Hi everyone, welcome back to the channel. In today's video, we're going to start doing work done by a variable force. So let's get started. So first thing to keep in mind, a variable force is a force that changes over the entire duration, right? So if it's 10 newtons, it's not going to stay 10 newtons the entire time. It's going to change over the period of time. Okay, so let's get started with one example. Springs are a great example of a variable force. So let's take a look. So let's start with what a normal spring looks like, which is right here where no force is applied. It's just a spring. The force of the spring in this case is going to the left, as you can see here, and the force of the person is going. So the force of the spring we'll label as Fs, okay? That's the force of the spring. As you can see in this example here, this person is stretching the spring, right? So they're pulling this way to the right. And the spring itself has a force that goes against it, kind of like a normal force would be, that goes to the left side, okay? And so what you see is they are going in exact opposites, right? Another example of this is when you compress a spring, you push it in really tightly. The force of the spring now goes this way to the right, and the force of your hand goes to the left. So they're still opposite, right? And so that's important to keep in mind, is that they're always going to be in opposite directions. The force of the spring is always going to oppose the motion being done to it, right? And we see that here is that it always opposes the outside force. So if you push on a spring, it'll push back. If you pull a spring, it'll try to get pulled back, okay? What you see though is that they're directly proportional. They're both changing, but they're always with respect to each other, right? And so what you can see here is that because of this proportionality, meaning that as the force of the pushing or pulling goes up, the force of the spring also goes up in the opposite direction. And since they both increase, what you get is a few interesting relationships here, right? Among those relationships is the force of the spring and the force of pressure, right? What you see is, like I said, they're both, as the spring increases, the pressure increases as well. So either you put pressure on the spring or you pull on the spring, right? And that equation is labeled right here. As you stretch or compress it, it exerts a force equal and opposite to the applied force. What you see as well is between the force of the spring and the displacement of the spring, there's also a relationship. And this is labeled by Hooke's law, which is F of S, which is the spring force, is equal to negative K, which is a constant, delta X, which is the change in displacement. So let's really break down what that means. So I want you to keep in mind, first thing, the spring resists motion like we just said. So it wants delta X to be 0. It doesn't want to move from its original position. So when delta X increases, so does the force of the spring to balance it, right? When it gets stretched or it gets compressed, it's trying to get back to 0. And so what you get is the spring exerts a force to try to bring itself back to delta X equals 0. Since the force of the spring and delta X are both increasing, right? They both go up in magnitude. You see that graphing them gives a linear relationship, right? So linear meaning that you can label it with the equation y equals mx plus b. And what you get is that y is equal to the force of the spring and x is just the change in x, right? And so what you see is, going back to this linear equation, y equals mx plus b, you can draw a graph, which we drew over here on the side, right? And what you get is that you can plot basically the spring force against the delta X, and you get this linear relationship. And when you think of a linear relationship and you go back to this equation of y equals mx plus b, The slope is basically the derivative of this graph right here. And since we're not in a calc class right now, let me just break that down. M is going to be the spring constant K, right? So whenever you plot these two things together, the slope is just going to be equal to the spring constant. So what is the spring constant, right? The spring constant is just telling you how much, it's a quantitative value, so it's a number for how much the spring wants to be at 0, right? How hard is it to pull the spring apart, and how hard it is to push the spring together, right? That's all that it's telling you, is it's a constant based on the specific spring that you're using and the force it applies. And then what you have left is the applied force and delta x. There's a relationship between those two as well. And so what you get is, again, it's the same as the spring force. When you increase the applied force, the delta x will change, right? Because you're physically either pushing on it or you're pulling on the spring. And so your force is increasing or decreasing, right? The magnitude is always going to be increasing because you're either pushing or pulling. And so what you get is, again, the delta x increases as well in magnitude. And so what you get is that since those two are both, again, directly proportional, you can get another linear relationship. And that's what we show over here, right? I did use the same graph for both because it's the same relationship. And again, what you get is M is equal to the spring constant K. So you can do it with both of these, and you will get that basically, if it's Fp, the applied force, or if it's the spring force, they're both directly proportional to the change in displacement. And so what you can say is that M is equal to the spring constant K. Again, that goes with how hard it is to pull the spring apart or to squeeze the spring together, right? And so we stated it right here. The spring constant K is how stiff the spring is, right? How much it resists motion, which we talked about a few times. And its units are in newtons per meter. And you're able to use this, again, in Hooke's law, which tells us that the force of the spring is equal to negative K delta X. That is Hooke's law. And this helps us figure out what the spring force is based on the displacement. It helps us figure out what K is. You're able to use this equation right here to figure out a lot of things that we'll go over later on in the video. But it's a very important relationship to keep in mind.